When dealing with tight spaces and high current requirements, like fitting a 400 amp 3-phase feeder into a 3-inch PVC conduit, traditional round conductors might not be the most efficient solution. Several compact copper conductor options are available, each with its own advantages and disadvantages. Understanding these options can help determine the best fit for your specific needs. Firstly, insulated copper busbars offer a compact and high current capacity solution. They are relatively easy to install, but they tend to be more expensive than cables and have limited flexibility. Manufacturers of insulated copper busbars include Bussmann, Eaton, NG. Secondly, flat ribbon conductors are known for being very compact and flexible. They can be easily terminated, making them a convenient choice for tight spaces. However, they generally have a lower current capacity than round conductors and may require special insulation. Manufacturers of flat ribbon conductors include Intertape Polymer Group and 3M. Thirdly, conductorized tubing provides both insulation and current conduction in a very compact form. This type of conductor can be useful where space is at a premium. However, it is less flexible than other options and may be difficult to terminate. Manufacturers of conductorized tubing include Amphenol, Belden, and Hellermann-Titan. Fourthly, rectangular copper conductors offer a good balance of compactness and high current capacity. They can be easily terminated, making them suitable for various applications. However, they are less flexible than round conductors and may require special insulation. Manufacturers of rectangular copper conductors include Southwire and General Cable. Considering the specific scenario of fitting a 400 amp 3-phase feeder into a 3-inch PVC conduit, flat ribbon conductors are generally recommended. Their compact size and flexibility make them well suited for navigating tight spaces and accommodating the ground conductor within the conduit. Flat ribbon conductors offer a viable solution for situations where traditional round conductors are too bulky. When using flat ribbon conductors, selecting the appropriate insulation is crucial to meet the required voltage rating. Be mindful of the ampacity of the conductor and size accordingly per NEC Table 310.15. It is also important to use appropriate fittings to transition from the compact conductors to standard cables at the termination points. Manufacturers such as Intertape Polymer Group and 3M are worth considering when sourcing flat ribbon conductors. Always adhere to all applicable electrical codes and consult with a qualified electrician for proper installation to ensure safety and compliance. Using compact conductors requires careful attention to detail, but it can be an effective way to overcome spatial limitations in electrical installations. The National Electrical Code, or NEC, provides guidelines for conductor sizing, conduit fill, and other critical aspects of electrical installations. Adhering to these guidelines ensures safety and compliance with industry standards. When dealing with compact conductors, it's essential to verify that the selected conductors meet the ampacity requirements for the intended load. Ampacity refers to the current carrying capacity of a conductor, and it is typically specified in amps. The NEC provides tables that list the ampacity of various conductors based on their size, material, and insulation type. Choosing a conductor with an adequate ampacity rating is crucial to prevent overheating and potential fire hazards. Conduit fill refers to the percentage of space occupied by conductors within a conduit. The NEC sets limits on conduit fill to ensure proper ventilation and prevent overheating. When using compact conductors, it is still necessary to calculate the conduit fill to ensure that it does not exceed the allowable limits. Factors such as the number of conductors, their size, and the type of conduit all affect the conduit fill calculation. In addition to ampacity and conduit fill, it's important to consider the voltage drop when selecting compact conductors. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can negatively impact the performance of electrical equipment and can even cause it to malfunction. The NEC provides guidelines for minimizing voltage drop by selecting conductors with appropriate sizes and lengths. Compact conductors may have a higher resistance per unit length compared to traditional round conductors, so it's important to carefully consider the voltage drop when using them. Furthermore, proper termination techniques are essential when working with compact conductors. Compact conductors may require specialized connectors or termination methods to ensure secure and reliable connection. Following the manufacturer's instructions for termination is crucial to prevent loose connections, overheating, and potential electrical hazards. In addition to the NEC, local electrical codes and regulations may also apply to electrical installations. It's important to be familiar with these local codes and regulations to ensure compliance. Consulting with a qualified electrician or electrical inspector can help navigate the complexities of electrical codes and ensure that the installation meets all applicable requirements. When selecting compact conductors, it's also important to consider the environmental conditions in which they will be used. Factors such as temperature, moisture, and exposure to chemicals can affect the performance and lifespan of conductors. Choosing conductors that are specifically designed for the intended environment is crucial to ensure long-term reliability. Moreover, consider the flexibility and ease of handling when choosing compact conductors. While flat ribbon conductors are known for their flexibility, other types of compact conductors may be less flexible. The ease of handling and installation can impact the overall efficiency of the project. Additionally, the cost of compact conductors can vary significantly depending on the type, size, and manufacturer. It's important to compare the costs of different options and consider the overall budget for the project. While compact conductors may offer advantages in terms of space saving, it's important to weigh the costs and benefits before making a decision. For example, insulated copper busbars are very compact and have a high current capacity, making them suitable for applications where space is limited and high current is required. However, they are generally more expensive than traditional cables and have limited flexibility. This makes them less suitable for applications where flexibility is important. Flat ribbon conductors, on the other hand, are very compact and flexible, making them suitable for applications where space is limited and flexibility is required. However, they generally have a lower current capacity than traditional round conductors. This makes them less suitable for applications where high current is required. Conductorized tubing is another option. It is very compact and provides both insulation and current conduction. This makes it suitable for applications where space is very limited and insulation is required. However, it is less flexible than other options and may be difficult to terminate. Rectangular copper conductors are yet another option. They are compact and have a high current capacity. This makes them suitable for applications where space is limited and high current is required. However, they are less flexible than round conductors. Each type of conductor has its own advantages and disadvantages, and the best choice depends on the specific requirements of the application. Choosing the right conductor is essential for ensuring the safety and reliability of the electrical system. By carefully considering the factors discussed above, it is possible to make an informed decision and select the most appropriate compact conductor for the job. Also consider the long-term reliability of the conductors chosen. Some compact conductors may be more susceptible to corrosion or degradation over time. Selecting conductors that are designed for long-term reliability can minimize the need for future maintenance and replacements. Furthermore, the availability of compact conductors may vary depending on the region and supplier. It's important to check the availability of the selected conductors before making a commitment to use them. If the selected conductors are not readily available, it may be necessary to consider alternative options. Also consider the lead time required to obtain the selected conductors. Some compact conductors may require a longer lead time than others. If the project has a tight timeline, it's important to factor in the lead time when selecting conductors. Furthermore, it is important to maintain detailed records of the compact conductors used in the electrical installation. These records should include the type, size, manufacturer, and installation date of each conductor. Maintaining accurate records can facilitate future maintenance and troubleshooting efforts. It is also important to provide adequate training to personnel who will be working with compact conductors. These conductors may require specialized installation techniques and procedures. Providing adequate training can minimize the risk of errors and ensure that the conductors are installed correctly. Compact conductors offer a valuable solution for electrical installations where space is limited. By carefully considering the factors discussed above, it is possible to select the most appropriate compact conductor for the job and ensure the safety and reliability of the electrical system. Make sure to consult with a qualified electrician before starting any electrical work. Electrical work can be dangerous and should only be performed by qualified professionals. An experienced electrician can assess the specific requirements of the installation and recommend the best compact conductor solution. Furthermore, an electrician can ensure that the installation complies with all applicable electrical codes and regulations. While compact conductors offer many advantages, they also have some limitations. For example, some compact conductors may be more difficult to work with than traditional round conductors. They may require specialized tools and techniques for cutting, stripping, and terminating. It is important to be aware of these limitations and to have the necessary tools and expertise before working with compact conductors. Also, the cost of compact conductors can be higher than the cost of traditional round conductors. This is because compact conductors often require more specialized manufacturing processes. It is important to weigh the costs and benefits of using compact conductors before making a decision. Additionally, it is important to consider the potential for future expansion or modification of the electrical system. If the system is likely to be expanded or modified in the future, it may be necessary to choose compact conductors that are compatible with the planned changes. For example, if the system is likely to require additional circuits in the future, it may be necessary to choose compact conductors that have sufficient capacity to accommodate the additional load. Also, make sure to select compact conductors that are compatible with the existing electrical infrastructure. If the existing infrastructure is designed for use with traditional round conductors, it may be necessary to make modifications to accommodate compact conductors. These modifications may include replacing connectors, conduits, or other components. Furthermore, consider the potential for electromagnetic interference, also known as EMI, when using compact conductors. Compact conductors may be more susceptible to EMI than traditional round conductors. If EMI is a concern, it may be necessary to take steps to mitigate it, such as using shielded cables or installing filters. Additionally, ensure that the compact conductors are properly supported and protected from physical damage. Compact conductors may be more vulnerable to damage than traditional round conductors. It is important to provide adequate support and protection to prevent damage from abrasion, impact, or other hazard. Also, be mindful of the potential for condensation or moisture accumulation within the conduit or enclosure. Condensation can lead to corrosion and electrical failure. It is important to take steps to prevent condensation, such as using watertight fittings and enclosures. Furthermore, it is important to periodically inspect the compact conductors for signs of damage or deterioration. Regular inspections can help to identify potential problems early on and prevent more serious issues from developing. When inspecting compact conductors, look for signs of corrosion, cracking, or abrasion. Also, check the tightness of connections and the integrity of insulation. If any problems are found, take corrective action promptly. This may involve replacing damaged conductors, tightening loose connections, or repairing damaged insulation. By following these guidelines, it is possible to safely and effectively use compact conductors in a wide range of electrical applications. Compact conductors offer a valuable solution for situations where space is limited, but it is important to be aware of their limitations and to take appropriate precautions to ensure safety and reliability.